All right, we're recording. You see my face. Everything is good. All right. We are going to continue with 2017 questions 3 and 4. Starting off with 3A, the first Calc inactive problem. All righty. And I love this problem because we've done countless examples of this one. This is my favorite kind, I'll be honest with you, and I really hope that this is the kind you see on your final exam. So let's start off with, let's read it. It says we got a graph right here. It says it's the graph of f prime. All right. Graph of f prime. The function f is differentiable on the closed interval -6 to 5 and satisfies the fact that f of -2, so like right here, f of -2 equals 7. And the graph of f prime, the derivative of f, consists of a semicircle, 3 line segments, as shown above. Cool. So if this is the graph of f prime, all right, and we got the initial condition, I'm going to go ahead and write this above right here. Then that means that, just making sure my audio is good here. That means that f of x is equal to, all right, my initial condition 7 plus the integral of -2 to some value we'll say is x. Okay, so if I want to know the value of any x value, that's 7 plus -2 to x of f of, and I'll use a different variable, t dt. And this is just the area under the curve, right? That's how that works. So part A should be super simple. It says find the values of f of -6 and f of 5. So f of 6, or f of -6, equals, and I'm just going to use this bad boy I came up with up here. It's going to be 7 plus -2 to -6 of f of t dt. And remember, that's just the area under the curve from -2 to -6. And because it's got a bigger number on the bottom of the integral, I'm going to go ahead and change it to 7 minus the integration -6 to -2 of f of t dt, because it's like we're working backwards, right? So all I have to do is 7 minus whatever the area between -6 and -2 is, right? So that's between here and here, and that is just a triangle, and that's, let's see, 1, 2, 3, 4 by 2, which makes this an area of 4. Yeah, makes it an area of 4. Oh, and I apologize. I meant to put f prime of t because we're taking the area underneath the curve of f prime. I apologize. F prime, f prime. But anyway, so that's going to be equal to 7 minus 4, which is 3. All right, so we did f of -6. Now if I want to do f of 5, that's going to be the same thing. F of 5 equals, it's going to be 7 plus the integral, -2 to 5 of f prime of t dt. Okay, so the area underneath the curve of the derivative function, right? And that's already kind of, lowest, like -2 to 5, so that's just going to be the area of this semicircle and the area of this triangle all the way to 5 there, okay? The area of that semicircle, so I'm going to say it's 7 plus, in parentheses, the area of the semicircle is 1/2 pi r squared. So it's going to be, and since it's underneath the x-axis, that's going to be -1/2 pi r squared, or 2 squared. Okay, so that's the area of the semicircle. And then plus the area of that triangle, that looks like it has a base of 3 and a height of 2. So that's 3 times 2 is 6, divided by 2 is 3. All right. And this simplifies down to -7 minus 2 pi plus 3, or 10 minus 2 pi. All right. So there you have it. That's f of -6 and f of 5, just taking the area underneath the curve and adding it to our initial value. Cool. All right. Looking at B. On what intervals is f increasing, and justify your answer? Easy enough. So let's start with the justification. I always start with the justification. f increasing, f increases, increases, how does that look right? F increases when, and remember we're describing it in terms of f prime, whenever f prime is of x is greater than 0, right? That's just what that means. Whenever the derivative is greater than 0, we have a positive slope, meaning f is increasing. Okay, so there's our justification. Now, when does that happen? If you look at our graph here, that happens on this interval right here, as well as this interval right here. Okay. So that first blue line on the left there, that interval looks like -6 inclusive, because -6 is positive. It's above the x-axis there. Comma, and we're going all the way to 2, which is where it's 0, or -2, sorry. And then from 2 to 5. And the answer key has closed brackets for all of those, but honestly, and then a lot of videos I watched on this problem because I was curious about the brackets, a lot of them actually just had open circles for all of it. They didn't include the endpoints or the critical points, just where it was above the x-axis. And that's fine too. They're not going to count off for the closed brackets portion for increasing and decreasing intervals. Okay. And well, that's it for B. All you had to do is just say the interval and justify why. So there we go. Let's go on to C. C says find the absolute minimum value. All right, we're on a closed interval and it's asking for the absolute minimum value. On the closed interval, -6 to 5, and justify your answer. Now, let's go ahead and start with the justification. We have, so I'll say this, absolute min occurs either at a critical point, which, remember, if you want to say a critical point is where f prime of x equals 0. So it either happens at a critical point or an endpoint. And that's just by definition. That's a bad definition of absolute minimum on a closed interval. It's either going to be at a critical point or an endpoint. So all we have to do now for our justification is just check all those points, and then we'll be good. Okay, so our endpoints are x equals -6 and 5, and our critical points occur at x equals -2 and 2, and technically 5, I guess, but that's already considered an endpoint. Okay, so I'll do the chart up here. Remember, for absolute extrema, you want to do a chart and just show all those values. So I'm going to put it in order: -6, -2, 2, and 5. Okay. And we're going to use kind of our formula from A and just think about the area underneath the curve to figure out those values, right? But if you remember from A, we already found f of -6 and f of 5. We already found the endpoints. F of -6 was, what was it? It was 3. And then f of 5 was 10 minus 2 pi, which 10 minus 2 pi, that's like 10 minus 6.28 approximately. So that's like almost saying 3.72 something. That's close enough, I think. Did I say that right? Yeah, I think that's right. Okay. And then, okay, so f of -2. Now remember, -2 is already given, right? F of -2 is 7. He's already told me that in the problem. And then 2 would just be 7, my initial value, and then plus pretty much the area of this semicircle, right? So that's going to be 7 plus -2 or minus -2 pi. So that's how you do that. And that's approximately, that's 7 minus 6 point something, which I wrote it down. That's like 0.72 something. 0.72 ... So It says find the absolute minimum value. Well, the absolute minimum value is going to be 7 minus 2 pi. That's the smallest value of those four numbers. So here we have our justification here in red. We have all of our points in the chart here, and the smallest of all those was 7 minus 2 pi. Cool. Let's move on. And then lastly, D. D says for each of f double prime of negative 5 and f double prime of 3, either find the value or explain why it does not exist. Okay. No justification needed for finding the actual value, only if it does not exist. So first of all, let's start with f double prime of negative 5. And we're given the graph of f prime. Remember that f double prime is going to be the derivative of the graph given, right? So that's just going to be the slope at the point. So at negative 5 right here, that's negative 1, 2, 3, 4. Negative 5 is like right here. All it wants to know is the slope at that point. Does that exist? Absolutely, it's a line. So f double prime of negative 5 is equal to just this slope, which if you can't tell, just use the endpoints of the endpoints of the line. You can just say let's see, what's the height there? It's 2 minus 0 over negative 6 minus negative 2, y minus y over x minus x, which is 2 over negative 4 or negative 1/2. Yeah, so that's f double prime of negative 5. All right, but let's think about the other one. Let's think about f. Let's think about f double prime of 3. All right, which if we look right here, it's asking for the slope at 3, which is this point right here, which we know at points we can't take the derivative. We know it does not exist, so we know there's no slope there at a jagged point like that. So I know that f double prime of 3 does not exist. Okay, I got the dang AC blowing right on me. I'm about to change that here in a second after this problem. So anyway, but we got to explain why. And I think this is a great problem for understanding this. We basically got to discuss it. We can't say because it's a sharp point. That's not a good enough reason for these types of problems. We got to discuss that the limit from the left, or the slope from the left, and the slope from the right are not the same slope. They have to be a nice smooth transition. It's got to be the same slope from left to right. Okay. So here's how we're going to talk about it. Okay. Well, how do I discuss this slope on the left side? So to 3 from the left. So you would say that the limit as x is approaching 3 from the left side. All right, and how we discuss that slope is just f prime of x minus f prime of 3 over x minus 3. Remember, that's just the definition of a derivative, or the definition of a slope, using the rate of change formula. Well, we know that this value is just equivalent to this slope right here, which if you do rise over run is just going to be equal to 2. Now, if I do the same limit as x is approaching 3 from the right of the same thing, so this is taking the slope of the derivative here, you know from the right side that slope is actually going to be a slope of negative 1 if you do rise over run. This is how you show that a jagged point does not exist. You have to discuss the limit or the slopes from the left and the right. I don't know if it would be good enough to say, hey, the slope from the left is 2 and the slope from the right is negative 1. I think they would like for you to discuss it as a limit. And then you would say that, those do not equal each other, so therefore it does not exist. And that's kind of the justification they're looking for there. Okay. All right, here's our answer key here. A, we used the initial condition, which was 7, so good job there. And we found both values. Okay, and notice how they came up with the same formula that we did. All right. B is 2 points. It's just the answer of the justification. So we said that it was increasing, and we said it was because f prime of x was greater than 0. Notice how they used brackets, but it's okay if you use parentheses. For C, we get 2 points for considering x equals 2. All right, because it's a critical point. and then an answer with justification. And the chart is your justification, and probably this explanation at the very beginning is justification, explaining that an absolute minimum is going to occur at a critical point or an endpoint. And then lastly, in D, the fact that we figured out f double prime of -5, which is just the slope, -1/2. And for saying that f double prime of 3 doesn't exist with an explanation. So you can't just say it does not exist. It wants this whole limit deal for its explanation. Okay. So that was question 3. Let's move on to question 4. Now, I was just about to turn the vent off of me, but it turned off on its own. Okay, so that's good. All right, question, so 4A here. Now, this is a very wordy problem, but I promise you it's not that bad once you just kind of break it down line at a time. So let's think about this. Just kind of picture this situation. At time equals 0, so our initial time here, we got a boiled potato. It is taken from a pot on a stove and left to cool in the kitchen. So the internal temperature of the potato is 91 degrees Celsius at time equals 0. So right when I take that out of the pot, it's at its hottest degree, right? It's at 91 degrees Celsius, which is really hot. And then the internal temperature of the potato is going to be greater than 27 degrees Celsius for all of time greater than 0. So I'm assuming, based off that explanation, that 27 degrees Celsius is probably the room temperature, right? So it's going to be at 91 degrees at its hottest, and it's going to gradually decrease until it gets to the room temperature of 27 degrees Celsius. And then it says the internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation. So it's not explicitly telling me h, it's just telling me the differential equation, -1/4 h minus 27, where h of t is measured in degrees Celsius, and our initial condition is h of 0 equals 91. So it looks like an exponential decay type problem, which we've done problems like this, but let's just take it one question at a time and not try to overwhelm ourselves. A says, write an equation for the line tangent to the graph of h at t. There we go. Line tangent, t equals 0. And then we're going to use that to approximate t equals 3. All right, I told y'all all the time, if you ever see a line tangent, I would go ahead and write down, all right, we need a point. All right, we need a slope. All right, what's my point? Well, if I'm at time equals 0, that point is 0, 91. It told me that in the problem. There's my point. What's my slope? Well, I got an equation for my slope, dh over dt. So my slope is going to be -1/4 h minus 27, or 91 minus 27, and that's going to be what my slope is equal to. Because at time equals 0, h is equal to 91, right? So this is going to tell me the slope. That's -1/4 times 64. Yes, 64. And that equals -16. Okay. So I got my point, I got my slope. My line tangent is going to be y minus 91 equals -16, x minus 0. Or you can just say y equals -16x plus 91. And I guess instead of y, I should probably say this is, well, no, I'll say y. This is tangent line, sorry, not h. So if it wants us, and well, instead of x, I guess I should say t. I should probably use the correct variables here. Instead of x, I should say t. Instead of y, I should probably say h, something like that. But anyway, that's my tangent line approximation. And if I want to approximate the value of time equals 3, I'm just going to do h of 3 approximately equal to -16 times 3 plus 91. Which, I wrote that down somewhere. That's it's equal to 43. So the temperature is approximately 43 degrees Celsius. All right, so part A wasn't bad, just line tangent and being able to use it to approximate a point. Okay. All right, that was A. Let's go on to B. B says, use the second derivative to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time equals 3. All right, well, remember second derivative, we're going to use that to determine that. That's talking about concavity, so it has to do something with concavity. I want you to remember something here with concavity. if it's concave up, remember that a linear approximation is below the curve, and if it's concave down, a linear approximation is above the curve, okay, or an overestimate. So that's how we use the second derivative to determine over or under estimates. It's just by definition. So we got to pretty much determine at time equals 3, is it going to be concave down or concave up? That's it. So let's start by finding d2h over dt squared. Well, the first derivative is equal to negative 1/4 h minus or plus 27 over 4. And if I take the derivative of that, it's going to be negative 1/4 dh over dt, and that's it. Because the derivative of h is dh over dt. Now this was implicit, so I have to plug back in dh over dt. So that's going to be equal to negative 1/4, and then dh over dt was negative 1/4 h minus 27, which reduces to positive 1/16 h minus 27. So there's my second derivative. Okay, there's my second derivative. Now, how do I figure out, because this only has h in it, so I can't just plug in time equals 3 into that. So I got to think about, all right, well, how do I know if it's concave up or concave down at time equals 3 to determine if it's an over or underestimate? Well, it all comes from this right here, that it's going to be 27 degrees Celsius, or it's going to be higher than 27 degrees Celsius for all time greater than 0. So at no time is the temperature going to be less than 27, meaning that this second derivative is always going to be positive. So I'm going to write that down. I'm going to say since h is greater than 27 for all time greater than 0, okay, since that's true, then my second derivative, d2h over dt squared, is going to be greater than 0 for all of time greater than 0, which includes time equals 3. So if that's the case, then h is concave up for all of time greater than 0. So because my temperature is always greater than 27, my second derivative is always greater than 0, and thus h is always concave up. So if it's always concave up, we have this situation right here, meaning that my answer in part A, so that means that my answer in part A, and I'm not going to write it out, was underestimate, because the tangent line is underneath the actual curve. So there you go. And that's just by definition. If it's concave up, it's going to be underestimate there. I thought that was pretty good problem. I feel like I was going to say something else about that. Oh yeah, and if you want to actually imagine the curve, I mean, think about it, guys. It's an exponential decay problem. You're starting off at 91 degrees, and it's never going to go past 27 degrees, so it's probably some exponential decay with a horizontal asymptote. So yeah, that's obviously going to be concave up. So that's going to be an under approximation, an underestimate. Okay. All right. So that was B, and let's finally move on to C. C says, for time less than 10, an alternate model for the internal temperature of the potato at time t minutes is the function g that satisfies the differential equation, boom. So we're given a new differential equation whenever we're between 0 and 10 minutes here. It says where g of t is measured in degrees Celsius, and we still have the same initial condition. Find an expression for g based on this model. What is the internal temperature of the time at time equals 3? A lot of words there, but all it wants us to do is go from g prime, or g prime back to g. So how do we do that? We integrate. Okay. So we initially start off with dg over dt. G equals negative g minus 27 to the 2/3. Well, this has your output g in it, so how do we integrate this? The only way to do this is separation of variables. Okay, you gotta separate the x's and the y's, or in this case the t's and the g's. Okay, I'm going to bring this quantity over here with dg, and I'm going to bring dt over to this side with my, I guess I'll leave the negative with it. So what this looks like is it's going to be 1 over g minus 27 to the 2/3 dg is equal to negative dt. All I did was just switch some things. I brought this over here and the dt to the other side. And now that I have everything separated, like on the left side I have g and dg, and on the right side I just have my dt. So I'm going to integrate each of these. Like if I integrate 1 over g minus 27, remember you can do this doing the power rule, bring 2/3 to the top, making it negative 2/3. You can add up, you can do power rule. You're going to have 3 times g minus 27 to the 1/3 equals negative t, because that's the integration of -1 here, and then plus c. Okay, so there's your integration. Now to solve for c, we're going to use the initial condition g of 0 equals 91. So I'm going to say 3 times 91 minus 27 to the 1/3 equals -0, or just 0, plus c. 91 minus 27 is 64. 64 to the 1/3 power is 4. 4 times 3 is 12. So 12 equals c. All right. So my equation that I got so far is 3 times g minus 27 to the 1/3 equals negative t plus c. Okay, negative t plus c. Now we just got to get g by itself. So I'm going to start by dividing. Oh, not plus c. Sorry, we figured out what c was. C was 12. Okay. So all I got to do is get g by itself. We're going to start by dividing by 3. So I'm going to go back over here to the left. We're going to divide. I'm going to go ahead and divide by 3 and cube everything, and then add 27. So I'm just going to go ahead and say g of t equals. That's going to be negative t plus 12 divided by 3, and then cubed, and then add 27. And yes, this is my expression for g of t doing separation of variables there. Or integration by parts. Wait, separation of variables. Yeah, separation of variables and integrating, right? So now all I have to do is use this model to figure out the temperature at time equals 3. So I'm going to do g of 3 equals. I'm going to plug 3 into that. That's going to be 9/3 or 3 cubed, which is 27. 27 is 54. All right. And remember, the answer in part A was 43, right? The answer in part A was 43, and that is an underestimate of what we actually got in part C, right? So, worked out in a way. Okay, cool. So that does it for number 4. Here's the answer key. Look what we did here. So we got a point for the slope. So that's why I say find the slope, negative 16. A point for the tangent line and a point for the approximation to be 43. In part B, part B was only worth 1 point. You believe that? It was just underestimate with a reason. And that was pretty much just talking about how it's concave up for all of t greater than 0. So thus is an underestimate. In part C, doing separation of variables here, that was worth 5 points. So 1 point for separating, which was getting it in this form here. 1 point for the correct antiderivatives, which is to right here. 1 point for the constant of integration, so getting c equals 12. 1 point for the equations involving g and t, which gets down to right here. And then 1 point for finding g of t and g of 3 to be 54. Man, oh man, that was a lot. Look at this, 0 out of 5 points if no separation of variables. So if you didn't recognize to do that, you got 0 out of 5 there. And you only got 2 points out of 5 if you didn't solve for C. So, all right. Well, I'm under 30 minutes. I still got 15 seconds before I am. I'm going to go ahead and try to stop the video. Good job, guys. Good luck, and let me know if you have any questions, and we'll finish the last two problems tomorrow.